Welcome, everybody. We're really excited to see so many of you here. I'll say it one more time before we get going here, and I'll lay out a couple ground rules so you can make your way through this platform here. You'll notice right now there's a pop-up on the bottom left-hand corner of your screen. If you haven't already, please take a second to fill out the survey. It will just give you an opportunity to enter any questions you'd like us to address at the end of this webinar during the Q&A session. Those are for questions that you may have come to this hoping to have answered, but it'll also help us understand how you're trying to apply this to your business, maybe for some future conversations. While I'm going over this, I'd like to walk through some of the different interactive elements that you'll see here on the platform we're using. So if you look in your top right-hand corner, you'll see that there is a chat, there's a Q&A, and there's a polls and handouts column there for you. So in the chat section, we'd love for you to give us some feedback as we go through anything that you liked or any thoughts that you have. The Q&A pillar that you see there is going to be an opportunity to answer questions or to ask questions, which we'll make note of as well for the Q&A session. And those are for questions that may come up as we talk through the material here. We won't be having any polls here today, but there are handouts that we would like to arm you with. So these are going to be some material that you can take away and reference at a later date. And then also, I do want to point out in the handout section that you'll see another opportunity if you don't get a chance to click this before the pop-up goes away to take that survey and share your feedback with us there. But with that, we'll go ahead and get started. So we are very excited collectively here to talk through what's been, to say the least, a very hot topic this year in machine learning, AI, and generative AI. What is the backbone of all of these in data. So I am Nick Schmidt. I am on the account team here at ClearScale. We are a premier tier consulting partner of Amazon Web Services. We've been doing this for quite a while. And alongside me is two outstanding minds in this space, and Kevin Epstein, who is our principal solutions architect, and Anthony Loss, who is our director of solution strategy, as well as an AWS APN partner ambassador. So I'm going to hand it off to Kevin to start diving into the conversation. Also, sorry, before I hand it off to you, Kevin, I just wanted to mention, if you do need to drop for any reason, we are going to be giving everybody we're going to send out a link of a recording of the webinar for you to reference at another time as well. So sorry about that, Kevin. Go ahead, take it away.
No worries. Thank you, Nick. So welcome, everyone. Really excited for you all to be here today with us. I want to dive right in, but before we get too far down the road, I wanted to set a couple really just definitions. We're going to be talking about generative AI a lot, and within Gen AI, you will often hear the term AI ML. And I wanted to just really sort of level set with what AI ML is, and then how that leads us down the road towards generative AI. So starting with AI, really just understanding what that is. And it really is just machines emulating the human process of thought and understanding to such a degree that we don't necessarily know whether it was a machine that provided us a response or a human. You may have heard of the Turing test. That is really the idea that if we cannot discern whether it was a human that responded to a question or a machine, then the machine would have been said to have passed the Turing test. The discipline of AI is used in a very wide variety of ways. But really what it's really great at is taking massive amounts of data and finding patterns and finding nuance in data for us. So some of the strong use cases, things you've seen a lot of, leading up till now, things like natural language processing. Imagine taking a recording and transcribing that to text, or planning. And we see this every day in our nav system in the car, where the nav system is continuously getting updated information. There may be traffic data, there may be accident data, there may be road closures. And the nav system is in real time always updating its intended path based on all of those inputs. So planning is a very important part of what AI does very, very well for us in a rapid succession. And then I mentioned two things like pattern recognition. As with any technology, there are good and bad use cases. So a couple of them that go without saying. If you have too little data, then your use case is probably bad for AI. That same use case can become good if you have a lot of data. The secondary or the backup to that is not only do you have to have a lot of data, it has to be of high quality. So there may be a lot of preparation work you have to do to the data to make it valuable and useful for training and machine learning and AI. Another area where it's not impossible to apply AI, but it is important to really think through the consequences. If you have a task that requires empathy or ethical considerations, you want to be really careful with this. And so the use case I like to talk about is, imagine that you're a lender, a customer comes to your website and they are interacting with your chatbot, and they've run afoul of some hard times, and they're not going to be able to make a payment. So the chatbot says, "How can I help you today?" And the user goes, "I've lost my job and I'm not going to be able to make my payments." And the chatbot goes, "Great," with an exclamation point. "Let's see how I can help." And that's probably not a great response to the problem. It could have been solved with a little bit of prompt engineering, but also it just really exposes the edge case of where we do and don't want to use AI, or at least we have to think a lot about how we're going to implement it. Then across the board, we're going to talk about some correlating Amazon services. Some of the services that we see in the AI space specifically are going to be things like Amazon Personalize and Transcribe, Comprehend and Lex as well. These are AI-powered services, but they're designed for developer consumption, meaning you don't have to be a data scientist or a data engineer to use these services. You will get the power of AI, but as a developer, all you have to do is implement the API and you're off to the races. Next, let's talk a little bit about machine learning, which is really sort of the first technical discipline inside of the whole idea of artificial intelligence. And what machine learning is really applying a whole lot of mathematical formulas and algorithms to a bunch of data. Usually we're trying to make a prediction. This might be binary, so it's a yes, no, true, false type of prediction. It may be a categorical prediction. So imagine using computer vision and training it on hundreds of images of dogs and cats, and then feeding it an image, and it will hopefully respond dog or cat correctly, as the case may be. We also categorize email. So for example, think about things like spam filtering. Is this email, is this spam or is this not spam? If it's spam, let's send it to the junk folder. If it's not, let's send it to the inbox. Next up is fraud detection. So think about the way your credit card works. If you're on a road trip and you happen to stop at some arbitrary gas station in the middle of nowhere that you've never visited before, it's highly possible that you will get a text message from your bank asking if that transaction was you or not. And if it was you, no harm, no foul. And if it wasn't, then they will kick off a whole bunch of processes for fraud mitigation. So there are also some poor use cases that we should talk about here. Sometimes it sounds interesting or innovative to apply machine learning to a business problem, but sometimes we don't need it, and it tends to become an expensive solution and overbearing solution to a simple problem. So if you go back to that use case I mentioned a little bit ago, if we were a lender, for example, and we had a very simple business rule that said we don't make loans to people who don't have a 620 score. You don't need machine learning to make that determination. That's a very simple if statement. We can solve for that very quickly. And that would be a really poor use of machine learning. It would be a very expensive way to answer a yes/no question. In this space as well, we have some correlated AWS services for you. The first two are actually interesting because they're hardware, but they're exposed through APIs and software. Trainium and Inferentia are custom silicon that AWS has for, number one, training the data and inferring the data. And inferences are really just a fancy way of saying prediction. So when we talk about Inferentia, we're talking about custom silicon that gives us the best price per prediction price points on the AWS platform. You will hear a lot about SageMaker, and SageMaker is not just a single product or service or feature. It's really a whole portfolio of features. So, and this really is aimed at the data scientists on your teams, or the data engineers on your teams, as well as the developers. Again, there's going to be services and features on SageMaker for pretty much everyone on your team. And then almost from the very beginning, AWS has always been open. So the open source frameworks are available. Things like PyTorch and MXNet are available in SageMaker. If you decide to launch an EC2 instance from an army, you can launch them with PyTorch and MXNet embedded on those instances as well. And that really drops us into the thing we really want to talk about today, which is generative artificial intelligence. And this is a branch of AI where we use massive amounts of training and learning to build a model that can generate new content. And so think about if you're in copywriting, maybe you wrote a blog post and now you need to think up a potential headline for that blog post. What you could do is you could take the text of your blog post, you could paste it into a large language model interface, could be some sort of web app, some sort of chatbot, and you might say, generate 5 potential headlines for this blog post. And so it understands what you're looking for. It understands you want a headline. It knows what a headline is, and it's going to read the text of the blog post that you wrote and come up with some potential solutions for you and headlines for you. Again, as always, there are edge cases where Gen AI either is not a great solution, or you have to put in a whole bunch more work to make it a good solution. So areas where things have to be extremely precise are possibly areas where you might want to think twice about using generative AI. In the name itself, it says generative, and so there's a little bit of uncertainty into exactly what we will get, although we should at least receive something close to what we were anticipating. And really, the headline service that Amazon makes available to us for generative AI is Amazon Bedrock. And we're going to talk a lot more about Bedrock. And at the end of the presentation, we have a demo as well, where we'll show you some of what the technology behind Bedrock can do. All right, so diving into generative AI a little bit more, generative AI fits in a subset of what we call deep learning. So if you think about AI as the technical domain, within AI, we have machine learning. Within machine learning, we have deep learning. And then within deep learning, we have generative AI. Generative AI is primarily possible due to the evolution of transformer models. If you are so inclined, there is a paper out there that is titled "All You Need Is Attention." It's a very technical read, but it's also a very good explainer as to what's actually happening with transformer models and how those evolve to delivering large language models to us. There's a small piece of information that's useful to understand, but not necessary to specifically know in operating a large language model is within the transformer models, there are both an encoder and a decoder. And the LLM, when we're making predictions, is only using the decoder. So again, it's a useful piece of understanding, but again, also really a detail that when you're actually using it, not necessarily important to you. What is important is that these models are trained on massive amounts of data. We're talking about usually hundreds of millions to billions of parameters. And to give you an idea of what a parameter is, it could be a piece of text, it could be a piece of information, it could be some data, but it can also be weights. So we can bias and weight that data in different ways. And we do all of this using neural networks. So if you're familiar with the terms of recurrent neural networks and convolutional neural networks, you'll be familiar with the technologies that are working under the hood to build these models. And then finally, generative AI takes a prompt of some sort, usually a way for us to interact with the model, to tell it what we're looking for it to quote unquote understand the intent of what we gave it, and then come back with a satisfactory response, something that will complete and satisfy the prompts that we generated for it. So some common use cases, we talked a little bit about this already. Think about text generation. So we could actually have it generate blog content for us. We could also feed it the blog content and say, generate a headline for us. Very common use case there that I think we've all seen and possibly played with the likes of ChatGPT. Image generation, the way we go about it is very similar. We prompt the model with what we're looking for. So we might say, make me a picture with a sailboat in the ocean with an island in the background. And we have a pretty good idea of roughly what we'll get, but we don't know exactly what we'll get until the LLM generates the image. Very much the same thing for video, but instead of for still images, we're doing this now for video. And for music generation, think about prompts that might be something like, I want a 60-second sample with featuring the bass guitar. I want drums in the background at about, let's say, 8 or 9 beats per minute, and also have a little bit of keyboard in the background as well. So that would be the prompt, and then the language model would go and generate the music for us. And then in the technology space, if you're a developer, you might use LLMs to actually generate code for you. So you might prompt it and say, write me a Python function that can upload data to Amazon's S3 storage. And the LLM will use its knowledge of Python language in general. It will also use its knowledge that it learned and was trained on the Amazon SDK, and then it would go and write the code for you. This all sort of leads me to the why AWS for Gen AI, and this, in many ways, it's a very simple answer. In many ways, it's very nuanced. The easiest answer here really is that from the beginning of cloud computing, Amazon has been acknowledged as the clear and outstanding leader of this space. The reason they are acknowledged as being the leader is because they have the richest and most diverse set of tools and features and services available to you. Whether you're a data scientist or a data engineer, services like SageMaker are going to help you complete the tasks that you have. If you're an application developer and you want to use AI-powered services, but you don't know about machine learning yourself, then things like textract or recognition or translate or transcribe, those are going to be very valuable to you. Possibly the single most important reason I think you would consider AWS for generative AI, and quite more broadly, all of your AI and cloud computing needs, is that the fact is that on the Bedrock platform, all of your data stays private to you. If you go to the landing page for Bedrock on the AWS website, you will see in the FAQs, they very clearly articulate this, that when you feed a model your business private proprietary data, none of that data will ever be used to train or improve a model for the platform as a whole or for others' benefit. That last piece, for others' benefit, is important because you can use Bedrock to train your own models, in which case data that you provide will be used to train a model, but that model is private to you and cannot be used by anyone else. So your data still remains private. And then lastly, Bedrock really does form and behave much like a clearinghouse for many models. And over time, we're going to see more models added to Bedrock. So if you look at this list of models, there's Amazon Titan, there's Jurassic from AI21 Labs, there's Llama from Meta, and there's Stable Diffusion from Stability AI. You can use all of these models today individually from all of these providers, but that means you have to learn 5 different APIs and all the details that go along with it. With Bedrock, we only have to learn a single API request, and we just modify the request with the different parameters depending on which model we want to use. So that makes Bedrock really simple, really interesting, and it's going to accelerate your use cases in AWS. So at this point, I'm going to hand off to my colleague Anthony, and he's going to talk a little bit more about the foundational models and large language models.
Yeah, thanks so much, Kevin. We appreciate you going into that technical depth and explaining the nuances of artificial intelligence and machine learning and deep learning and a lot of these words that get thrown around in the industry today. And I think it's a good segue into what I'm about to talk about now is foundation models or foundational models and large language models. These terms are thrown around pretty loosely, and I want to make sure that we have a good understanding of what the difference is between a foundational model and a large language model. And so I'll start with a foundational model. And essentially, these are, it's in the title. These are the foundations of all generative AI models. They could be a variety of purposes across different domains. So some of the things that they do, we might all be aware of, is translation, question answering, even image creation and recognition. What makes them unique is that they serve a solid base upon which specialized models or applications can be built to meet specific needs. So Kevin just talked a little bit about Amazon Bedrock, and you saw a list of available APIs to models that are available in Amazon Bedrock. And those models are considered foundational models. And the reason that is because they can provide a variety of different purposes of some of the things I just said, image generation, translation, things like that, depending on what the business use case is. And when we say foundation models are the base for specialty models, that leads us right to a large language model. And a large language model is a type of foundation model, but they specifically focus on language. And so they're capable of performing tasks like text completion, summarization, translation, question answering, but they primarily deal with textual data. If anyone's ever written a text message or written an email and there's an automated option to have the text or email completed, you'll see, the rest of the sentence it's suggesting. That's coming from a model. It's coming from a machine learning model that is taking vectors and text embeddings and suggesting based on mathematical reasoning what the next word should be. And so that's a specific use case. And these models are especially valuable in applications that require an understanding of natural language, making them integral to various text-based tasks. So in summary, while both foundational and large language models are capable of question answering and translation, foundational models have a broader range of capabilities, like we talked about image recognition or generation, and serve as a basis for building specialized applications, while large language models are specialized in dealing with textual data that are essential for tasks that require natural language understanding. With that being said, I want to talk about different ways you can work with a large language model. And essentially, there's a lot of different ways you can work with a large language model or an LLM. But we're going to talk about three different ways, the three most common ways to work with an LLM within your business or within your application, your AWS environment, or however you feel is necessary to work with an LLM. The first way is to train a custom LLM. Now, this approach involves creating a model that's tailored to your specific needs and requirements. This can be really time intensive and requires significant resources. But the payoff is that you have a model that fits your specific use case. It's custom to your business, and it is trained in a way that is biased towards how you want it to behave and act. A lot of enterprise customers are training their own LLM, but it takes a significant amount of resources and money and time to do that. The second method is to tune a general purpose LLM. This is known as LLM ops, LLM operations. This involves taking a pre-trained model and doing things like fine-tuning it, parameterizing it on a specific data set to make it more suitable for a particular application. This strikes a balance between customization and resource utilization. This is probably the most common way that enterprises and small medium businesses are working with LLMs is by taking LLM API and fine-tuning it to be able to work in their specific use case. Now, Are you downloading and training a custom model when you're working with when you're fine-tuning a model? No, those are two different things. Fine-tuning it is essentially taking data and or prompt responses and adjusting the model accordingly based on how you want to call the API. The third approach is to prompt a general purpose LLM. This is when you feed the model a specific prompt or set of instructions to generate desired outputs. This method is less resource intensive and can be a quick way to leverage LLM for your needs. This is a very, very common way that we're seeing customers work with LLMs. And specifically, if you look at the right side of the screen, you'll see a little diagram there. This is what is known as retrieval augmented generation, or RAG. And when you do retrieval augmented generation, you're essentially having a prompt that is part of the process, and you're using a query. So you could be asking a question, commanding a response, whatever it is that you want the LLM to do. And the first step it takes is it goes to a centralized data store or a knowledge source that you've predefined, and it gathers relevant information or enhanced context that has something to do with the question or the demand or required output that you're trying to seek within those knowledge sources. And so it'll take a gist of information along with the prompt and the query and send all of that to a large language model and say, hey, you figure it out. Here's the prompt, here's the query, here's the relevant information, swift through it, figure it out, and get back to me with an answer. And then it does, and then it will get back with an answer based on the text that you're giving it, and that is known as RAG, Retrieval Augmented Generation. And that is a very, very popular way that businesses are working with large language models today, so they don't have to fine-tune a large language model if they don't have the in-house expertise. They certainly don't have to train a custom LLM. All they have to do is have a knowledge base, like a database or some sort of knowledge store, be able to ask it simple questions or demand simple responses, and then send all of the relevant information to a large language model and say, hey, figure it out and get me an answer. And that's where large language models can be really, really powerful because it's dealing with contextual data and providing an output. Amazon Bedrock. This is by far, I've been working in AWS for close to 10 years. And I will say that Bedrock is one of the most exciting AWS releases that I have seen in my tenure working with AWS. And essentially we'll go through it pretty quickly here, but I want to make sure we all have an understanding of the benefits of Amazon Bedrock. The first one is that it leverages agents to deliver Gen AI to your applications. What are agents? Agents are a managed service within Amazon Bedrock that automatically break down tasks and create an orchestration plan. So you don't need system integration or infrastructure management to be able to use things like retrieval augmented generation, which I talked about in the past. Agents can automatically handle that for you, given you configure them in the right way. If you're looking to configure them in the right way, that's where a partner like ClearScale can come in and help implement an Amazon Bedrock solution for you. So agents are really, really important as they are a managed service within Amazon Bedrock for configuring how you want to work with a foundational model. API security with your own data. Right now, when services like ChatGPT or GPT-4 became available, 3.5 Turbo, however you want to, whatever model you want to use, enterprises got super nervous about using those because they'd have to send their data to traverse the internet to find an answer. So think of that retrieval augmented generation I talked about. You have to send the contextual data that have something to do with it to the LLM. And when you use something like a GPT-4, you have to do that over the internet. And customers are really, really nervous about this because they don't want to send their proprietary data over the internet. Well, with Amazon Bedrock, you don't need to do that anymore because you can leverage something known as AWS Private Link to be able to send your data to the LLM API or the foundational model API only over the AWS backbone, the network backbone. So it doesn't have to traverse the internet. And you can also encrypt it with TLS and at rest with KMS keys, key management service. So it becomes a lot safer and a lot more efficient in terms of security when you use something like Bedrock, so your data does not have to traverse the internet. Finally, you can leverage tools like CloudWatch, CloudTrail, and IAM to be able to monitor and monitor security in the usage of your Amazon Bedrock workflow. And I think that's really important as you start to open up this world of foundational and large language models to your employees and to even your customers, is to monitor what's being used, monitor the API calls, make sure you have a usage CloudWatch dashboard so it doesn't get out of control, and then finally control who can access it from an IAM and identity access management service perspective, so that you're not having unauthorized access to your workflow. And that's what Bedrock does. It allows you to have these components in your AWS environment, and that's really what separates Amazon Bedrock as an API layer as it compares to something like an OpenAI or another third-party model calling service. Okay, so what does ClearScale have to do with any of this? Why are we here? That's a good question. We're here to educate as much as we can, but we're also here to let you know that we, as a company, lay the groundwork to broker the introduction between your application and a large language model or foundational model API with what we call GenAI App Link. And GenAI App Link is how ClearScale helps their customers be able to leverage access to foundational and LLM API models. It's a methodology that ClearScale follows, but it's also a prototype as well. It's a prototype to show what ClearScale can do for your environment, for your application, and how it can be a link, literally, into what you're using today to start using LLM or foundational services. So it's an integration to Amazon Bedrock, and it has built-in use cases. It's a multifaceted prototype that includes document summarization, retrieval augmented generation, or RAG, what we talked about earlier, SQL query with natural language, or image generation, and even more that's being added to it every day. And so this makes it relevant to your application by incorporating purpose-built prompts and responses that are made for your business, okay? And along with this, we provide extensive documentation on how to apply the solution, scale it as it directly relates to your application. So when you think about incorporating a foundational or a generative AI feature into your application or workflow, I want you to think about GenAI App Link, which is here at ClearScale. And what that is a methodology, and it's a tool that we use to incorporate these types of technologies for our customers. And it starts with a proof of concept, or it starts with a prototype. And a prototype shows all the different things that you can do, and then builds based on that to make this a production-ready solution in your current application workflow. And that's why we call it App Link, is because it's to enhance or modernize what you're doing today to be able to leverage tools like generative AI. And I don't think I can explain it anymore. I feel like we got to show you. And that's why we've scheduled a demo here with Kevin Epstein, who we just talked a little bit earlier, to show you what it looks like with App Link. He's going to go through some of the features and functionalities, but he's also going to show what's possible when you use something like generative AI in your own workflow, and what we can do here at ClearScale to implement that just based on this short little prototype that we've built for showing you. So I'll pause there and I'll hand it back to Kevin. And Kevin, we'd love if you can walk us through GenAI App Link.
Great, thanks, Anthony. So I'm going to share my screen, and you're going to see App Link. So you'll see we have a landing page here, App Link. There's a bunch of text. It may be a little bit small for you to read. It's not important for this particular demo that you can necessarily read all the words. It is important, though, that you can kind of see what App Link is doing. So as we discussed, there are a couple different ways we can use Bedrock. We also talked a little bit about things like document summarization. This is the first one. So what I have here is I have prepared a sample meeting transcript that I found on the internet. it was available, freely available. And really, it's just a sample. It appears to be a small town or city going through a meeting, and it's the agenda and the minutes of the meeting. It's a transcript. And so you can see that everyone received their agenda. There was also a notice that somebody's name was omitted from a special report. There was also further on, I think there's somewhere in here there's talk about needing to purchase a laptop and where the funds for that would come from. But this is a long sort of transcript, and somebody may need to know what happened in the meeting, but they don't need to know everything. And so we maybe take that transcript and we'll summarize it. And what's happening in the background here is we've taken this text. There's a couple technical things that are happening. We're using a framework called LangChain, which you may or may not have heard of. What it's actually doing is it's breaking down this long text into more sort of manageable bits. And then what it does is it looks for what it believes are the most important bits within each of those segments. And then what it will do is reconstruct them as a summarized thing. So you'll see here that they made a motion to approve the transfer of funds from one account to purchase a laptop. That was something that they did. They also talked about some old business about making a motion to sell property near an airport that got withdrawn. And at the end of the day, the move, various other things happened, and the meeting concluded with no further discussion. Why I mentioned to you at the top of this call, in this webinar, was you cannot, if you're looking for highly precise, repeatable outcomes, generative AI is something you have to think very carefully about before you do it. So if I take that exact same text without any modification whatsoever and say, summarize my text again, I will get a slightly similar but not the same summary. And the point being here is because it's generative in nature and because it has certain amount of creative freedom, some of which we can influence. We can there's a parameter called temperature. We can make it warmer or cooler. The warmer you make it, the more freedom it has to be creative. The cooler you make it, the less creative it will be. And here you can actually see it's quite a different summary, but ultimately the takeaways will be still very similar. So, we're still talking about discussing the motion to sell the property, and a couple of other things that came out of this meeting. So you can kind of see in the generative nature of the technology where each time I do it, I'm going to get a slightly different outcome. And that is actually kind of by design. The next thing I wanted to show you, and Anthony mentioned this quite a bit, retrieval or augmented generation. This is where we pre-populate some sort of a data store, a database, with data that we own and collate and collect over time. In this particular case, I've preloaded this the data storage with a couple PDFs. One talks about security on the AWS platform. Another one talks about generative AI, by MIT. And so if we ask the model a couple questions. So, for example, let's ask the model, what are some of the ways that I might be able to secure my AWS environment? And we'll hit submit. What this is doing is we're using a language model to create what's called embeddings for this question. So we're actually turning this question into an array of numbers. And then we're doing a distance or a similarity search in something called a vector store. And we're getting answers. At that point, the similarity search or the vector search isn't really AI as such. It's just a mathematical, how close are the intent of this question to answers I have in my database. And so you can see I asked, well, hey, how are some ways that I can secure my Amazon environment? And it came back with a couple. It said, hey, use client-side encryption. It said, keep your OSs up to date and patched. It talks about things like securing your infrastructure, managing identities and permission. And it talks about using Amazon services like Shield to protect against DDoS and Amazon secrets for storing secrets. So pretty good responses to the question. Instead of sort of a keyword search where it might send me to a page and then I would have to read that page, it's taken the information in those pages, distilled them down, and given me a response that I can go and use. So we could try something else here, and we could ask it a question such like, let's try this one. What are executives most worried about with generative AI? I'm asking this question because it is completely different from the security question I asked just a few moments ago, and we're actually going to get answers from a completely different document. But the user doesn't know that. The user just asks a question of the system, and the system will figure out which document to go and get the answers from, and then come back with an answer. And so in this case, we'll get an answer in just a moment here, and we'll probably get a couple of answers, one of which is likely to be that executives are worried about things like private data being leaked. And so you can see here, there's concern around commercially sensitive IP or copyright infringement. We've heard a lot of this in the news, in fact, particularly with OpenAI and other folks like that. Anthony talked about having to expose data to our models and the security and privacy that goes behind them. And then obviously, excuse me, there are concerns that lawmakers and regulators still have to figure out how we want to govern how Gen AI can be used. So the interesting thing here is we asked two very different types of questions. One was more technical, how do I secure my AWS environment? Another one was more sort of executive level strategy type questions. And all of the data came from a repository. The user didn't have to go and search for the data and then read the document and find the answers. They just came to a text prompt and asked the question and got the answer. So it generates pretty powerful capabilities for organizations, especially if you think about all the data that you own in your environment. Another thing I wanted to really show really quickly is not only can we feed PDFs and text documents and images to the model, but we can actually connect generative models directly to actual SQL databases. So in the background, I have a RDS MySQL database. It has a pretty classic machine learning data set for Titanic survivors. And we can query this database using natural language. So we'll do a plain English query, or we can actually write some SQL queries and we'll get an answer either way. So for example, here, I'm going to say, what was the name of the youngest survivor? And we'll do a plain English query, and we should get a response back with the correct name. And you'll see here that the name of the survivor, his name was Master Assad Alexander Thomas. And if I were to write a SQL query, that this exact same query might look something like this. And so we'll write a SQL query, and we'll get the answer as well. And in this case, we get the same answer. So the important thing here to see is that you don't need a database administrator or a SQL developer to write queries for you. You can now expose your database to your users, and they can ask a plain English question of the database and get some answers back as well. So this is pretty powerful technologies. And then, of course, there's image generation. So if we were to go and prompt the engine, so again, if we think about, let's try this one. The prompt here is, the wild plains of Africa with mountains in the background. Time of day is sunset, and the mountains are in different shades of colors that might be appropriate for sunset. And in the foreground, we have a hot air balloon. And so we're going to take our chances and see what we get over here. And this is using the Stability AI language model that we have here. And here you can see basically it's taken what I prompted it. It's done an okay job, I think. We have some open plains, we have some mountains. Quite clearly, it looks like it's at sunset, and we have a hot air balloon in the background. And you can see here, this was the prompt that we gave the engine to generate this image. I'm not going to talk about indexing documents or flushing indexes. This is really just these are maintenance capabilities, but this is how, if I were to index a document, I would add a PDF here, and it would index the document. Indexing it really means that it deconstructs all the text that's in the PDF. It does that thing that I mentioned before, embedding, and then it stores those embeddings in a vector database. And then later on, we can do searches, and we're doing similarity or distance searches to those vectors. Once we have those answers, we can then construct a plain English response for the user query. So that's the demonstration. I hope that was helpful. And Nick, I'm going to hand back to you and see if we had any questions that we wanted to cover off.
All right. Thank you so much, Kevin, Anthony. I'm going to go to the next slide here. We're going to pivot here into the Q&A section. So I noticed that we didn't get really too many questions here, but that's okay. We did get some previously from the survey, so we do appreciate that. Before we dive into the Q&A session, I just wanted to point out here that we'd be happy to get in touch at any time if you'd like to have a more personalized conversation around your business and the things that we discussed today, or really anything that you've been thinking about using cloud technology for on AWS or just in general. So you have my contact information here. You'll notice that there is a QR code there that you can scan, which should take you to a calendar link for my calendar. And please feel free to book time on my calendar that way, or get in touch with me via any of those other outlets that you see listed there. It looks like we actually did just get a question roll in here. So we'll dive into it. We'll start there. What is the cost related with this? I'm assuming that applies to both Bedrock and to Avalanche. So Kevin, would you mind kind of walking through what cost looks like both on Bedrock and through Appling?
Sure. So on the AWS side of things, there's a couple different costs, as you might imagine, but specifically for Bedrock, the way they price things out is that the different model providers have a base cost that they charge per token. And token is just a fancy word for saying words or collections of text characters. And it's usually priced in per million. So, for example, I think if you use the Claude model from Anthropic, I think it might be $30-something per million tokens. If you use Amazon's Titan model, I think it may be $11 per million tokens. And tokens are measured both as the number of tokens coming in and as tokens going out. So it is something you need to pay attention to. If you're using this internal to a small team, maybe millions of tokens will go a long way for you. If you're exposing this to the internet and you're expecting, hundreds of millions of users to use this, then those millions of tokens are going to get used up pretty quickly. So you do have to do a little bit of work to try and figure out how much it will cost you specifically. You won't know this just by saying, well, I have this type of question, etc. You'll actually have to do some modeling and some experimenting to figure it out. But roughly speaking, it's done in a price per millions of tokens, and then you would extrapolate how many millions of tokens you think you're going to consume through a given month. Of course, there are other AWS services that we would have to consider. So whatever database storage services you're using, things like Amazon S3, things like Amazon RDS, all of those services also have a cost. But specific to Bedrock, we're going to focus on the model provider, their cost per millions of tokens.
Perfect. And Kevin, too, just to elaborate a bit further there, I think that's something that we can certainly help flesh out in those one-off conversations about, strategizing and planning for, how many tokens might be needed there, depending on the intended use case.
Yeah, absolutely. So like a use case where you're doing a lot of document summarization, you will necessarily use a lot more tokens. Where a use case where you're prompting a image generation engine, we would probably use far fewer tokens, and we would have to just model out what your averages are.
Perfect. We just got another question that popped up as well. So what use cases do you like best to work with as it relates to Bedrock?
And is that for Anthony or myself?
Let's give this one to Anthony.
What use cases that we like to work with specifically for Bedrock? Is that the question?
Yeah. What are some examples, I should say, of strong use cases for Bedrock? And maybe let's talk about it by an industry. Let's say healthcare, for example.
Yeah, that's a great question. So Bedrock, as it relates to something like healthcare, is really great at summarizing findings. It depends on what model you use first. It depends on what foundational model. It could be anything, right? It could be from text generation or image generation that has something to do with, maybe it's healthcare. It can say, hey, look at this image and tell me what's wrong with this lung, or tell me what's broken in this bone, or whatever the case may be. And Bedrock can be used for that. But specifically, what I've seen the most is summarization of findings. So if I have 100 different health reports, right, and I need to know what is the trend among them, or to summarize them and categorize them in some sort of categorical methodology, then you can use Amazon Bedrock's Titan model or its Claude model to be able to summarize what it's seeing in all of these documents and provide an actionable output and suggested output for something like that as it relates to healthcare. You can also use that in finance, where it's, hey, we have a lot of these financial documents that are suggesting many different things. Here's 1,000 of them. Summarize what they're trying to say and give me the trend on it. And watch it do that so much faster than if you were to have someone read through all those and provide summaries for that. So that's a good use case for Bedrock in healthcare and in finance for you.
Awesome, thank you, Anthony. And yeah, I think that point's at a really great thing to mention and hit on. It's we have attendees here from various industries, and if you'd like to talk about your industry in particular and learn a little bit more, again, please book some time with us, and we can continue the conversation. So we can talk about how to make best use of these, both Bedrock and some of the other services in your industry in particular, in your business in particular. So thank you for that question, Bruce. Another question that we have here. Let's stay on the topic of Bedrock. Kevin, is Bedrock available to everybody at this point?
So Bedrock itself is available to everyone. It is generally available. There are definitely still some preview features and functionality that's not available to everyone. So that will be coming later on. There are things, some of the agent capability is not available to everyone just yet. If it looks like it's interesting to you, though, you should contact AWS or work with us to contact AWS to try and get that enabled and add you to the preview. The only caveat there is when things are in preview, we're more interested in experimenting with it, with playing with it. I would hesitate to say push it to production while things are in preview. Not only because we're not, will it work or will it not work, but more because when things are in preview, things can change. And so you don't want to sort of build your product strategy on preview, and then when it goes to production, it operates a little different, and then you have to go and refactor your application again a little bit. So the short answer is yes, anyone can play with it. The longer answer is some functionality and features are not available to everyone. And some of the models are also not all fully available to you. So things like Titan are available to you. Things like Claude are available to you. Things like Cohere's Command may or may not be available to you. And I think Stability AI's model is in preview as well.
Perfect. Thank you, Kevin. And I think that feeds into another good question that we got as well. Bedrock, is it the only way to do generative AI on AWS, or are there other options to go forward with, depending on use cases or availability, really?
So, I mean, it's not the only way. AWS has many tools and services in the AI and ML space. We touched on SageMaker a number of times, and you could actually go and build your own model using SageMaker, host it, train it, etc. And you could use SageMaker. what Bedrock is doing for you is abstracting away a lot of the complexity of SageMaker and just making it very simple to provision and consume these models. Under the hood, they're trained for us. Under the hood, they're hosted for us. So all of that work that we would otherwise have to do with SageMaker ourselves, Bedrock is doing for us. But it's by no means the only way to do it. If you wanted to use SageMaker, you could absolutely do it. You could even just launch an EC2 instance and do all the work on a virtual machine yourself. I'd discourage that. It seems like a lot of work where this is all being done for you, but it is possible.
Awesome. Thank you, Kevin. Anthony, as you are looking into Bedrock and what large language model to use, how can you go about making that decision about which would be the best fit for you?
That's a good question. Before I would start looking at the different models, I would start looking internally and finding out and uncovering what are the expected business outcomes for using Gen AI. And so once I can clearly identify this is the outcome that I'm looking for and this is the value I'm trying to achieve, then I can look at the number of models within Bedrock and choose based on the business outcome that I currently have. So for example, if I'll take it back to the healthcare example, right? My business outcome is to summarize many documents. That's the output. The outcome is, okay, I want to have this so I can identify trends faster and be on top of different healthcare issues. Well, if that's the case, then I need something to be able to summarize this in a very effective way. And so maybe I can use something like Amazon Titan because it says it's good for document summarization, right? So if it's good for document summarization that achieves to my business outcome, then I'm going to use that model. So it starts with identifying internally what you're trying to do, what the value is and what that outcome is. And then picking a model based on the capabilities of that becomes secondary and very easy to do once you identify internally what you're trying to do. Does that make sense?
Yeah, it makes sense to me. And I think this is where we can really help as well, right? We can talk through the business objectives, the vision that you have, and help you narrow that down as well. So strongly encourage if you have some time in the coming weeks to book some time with us. Let's continue the conversation on a personalized basis, and we can help you determine, how to get to where you envision yourself using the technology in the best way possible. We are running up on time here, so I think that will wrap it up for the Q&A session for now. Rest assured, any questions that went unanswered, we will be reaching out and answering those on a one-off basis. Again, I do want to encourage you, if you haven't done so already, to download the handouts that are available to you in that handouts column. But other than that, we greatly appreciate your attendance here. We hope you learned a lot. And I want to say thank you to Kevin and Anthony for this comprehensive walkthrough. I know this was more broad-reaching, but we're happy to have a more individual conversation at a later date. So thank you so much. And just as another reminder, we will send out a recording here for everybody that was in attendance to view again at another time if it's something that you might want to reflect back on. So with that, we're going to close out. But thank you so much, everybody. And I hope to speak soon.
Thanks, everyone.
Thank you all.